This is the X-Spiral pneumatic version. This is a 2.5-inch version, which means that the housings are 2.5 inches in diameter, and this is a 40-inch membrane, so it's 25-40 membranes, 2.5 inches diameter by 40 inches long. And as you can see, this is a pneumatic version, so it is completely powered by air. There is no electricity whatsoever in this system, so it is safe to operate with volatile solvents in a controlled environment, in a C1D1 type environment. And the operation is relatively simple. Through this port, you import your micellar stream, which is your oil dissolved in any solvent, pretty much. Hexane, pentane, heptane, ethanol, methanol, isopropanol. This is your air connection right here. A couple valves to control your inlet rate. And then you have your permeate and your retentate. So depending on your application, you're going to get different things here. This machine is capable of doing solvent recovery, so you can recover your ethanol from your process stream, and what you're going to get out is clean ethanol with non-detectable cannabinoids. You're going to remove about 90% of those solvents, and in the other tube you're going to have your crude oil at around a 2-to-1 ratio from your original stream. So you get about 90% of the work done. That 2-to-1 ratio then proceeds to either a rotary evaporator, a falling film evaporator if you've already got one, or even a decarb vessel if your operation is small enough, if your batches aren't so big. Typically you can just strip the residual solvent in a decarb and then decarb after that, so you don't have to bother with it anymore. And so this machine operates something called the cross-flow. All of these types of machines are cross-flow filters, which means that there is solution flowing tangentially through these tubes. And so when a particle lodges into the membrane, the filter element that's inside, the water flowing tangentially across the membrane surface actually plucks out that particle and cleans your filter. So this happens in real time. So in this particular filter, you can have a typical process stream of about 30 gallons per hour. So you're going to have about 30 gallons per hour coming in through this pipe and 30 gallons in total coming out of those two pipes. But through the surface of these membranes, you're going to have about 4 gallons per minute flowing through them. And so this is achieved by using two pumps. You have one pump for the cross flow, which is basically, think about it like recirculating your fluid within the system. So within those 4 housings, you're going to be recirculating at a rate of 4 gallons per minute. But then the system as a whole with the other pump, one's called a loop pump, which recirculates, a recirculating pump, and that's creating your cross flow. And then the other pump is your feed pump, which does the function of suctioning the fluid into your system, and it goes out the other end. And so the operation of it, once you know that you're using a crossflow, how the feed and the loop pump works. Since this is a pneumatically driven pump, these valves, and with air, you control the feed. And so that's going to determine how much your final concentration is going to be. So if you're filtering at 2:1, if your final product, you want it to be 2:1, you can control how many gallons per hour you flow through the machine, and that determines how much what your solution in the end is going to be like. You could run it faster. You have that benefit of being able to throttle up or down. You could throttle this up to 90 gallons per hour if you wanted to, but again, in a different type of membrane, in a different type of application, but you have that versatility, and you can check through simple, easy to read gauges, right? These are flow meters, and you can see the little lines, and it'll tell you 1 gallon per minute. And then this is the crossflow filter. This is your flow rate. So 1 gallon per minute is 60 gallons per hour. And then your crossflow, we can measure up to 38 liters per minute or 10 gallons per minute. And like I said, you're going to be around these ranges. And so you can set the crossflow again, with your recirculation, you just modify the air and you open and close these valves to control how fast. And so as you're moving this valve, this needle is going to go up and down. And so you read your manufacturer specifications on what the manufacturer recommends the crossflow for each individual membrane to be, and you adjust accordingly. And then you also adjust according to your application. And so these are moving targets because we all know the materials change. You might have more sugars, more fats, more waxes, more whatever, or you might have a different concentration or a different solvent. So these are all moving targets. But with this type of crossflow filter, you can adjust your crossflow, you can adjust your feed, all those things relatively simply in a C1D1 environment without fear of any kind of explosion or whatnot, because these are completely pneumatic. Again, they don't use any electricity. The crossflow is a completely sealed system. You don't need to input any secondary fluid to perform that self-cleaning function, and the self-cleaning function is continuous. So this filter continuously cleans itself. And so these membranes, because of that, will last about a year. It depends. You have to care for them correctly. The technology comes from the desalination industry. The technology, though this machine is new, and the application to botanicals is relatively new, the system itself, the technology itself is tried and true, 20 years old or whatnot. So this right here is a heat exchanger. This machine operates at room temperature. Your feed is typically done at room temperature. However, if you want, you can feed your solution colder, and that just depends on your application. You may find that running it slightly colder than room temperature, you get better results. You can also play with the concentration of the solution. So you could feed a 20:1 solution straight out of your centrifuge, or you could feed a more concentrate solution, maybe a 10:1 solution. You can use ethanol, you can use methanol, all those things to dial in your SOP. But the heat exchanger in this system is primarily used to remove heat from your system, because the pumps generate a certain amount of heat. And so this is an inline heat exchanger that, depending on the application, can be fitted with an external chiller to remove the heat that the pumps are generating. And so on a small system like this, I believe it's about a kilowatt of cooling capacity that's necessary to remove the function. So you don't need a big chiller. There may be other instances where you may wish to use a chiller, but in general, it's not, especially for solvent recovery. We've actually found that for solvent recovery, warm solutions flow better and recover better than cold solutions. You remove these, pull this out, and your membrane's inside. There may be an adapter or whatnot, but that's how you remove them. These systems are not made to be constantly having the membranes changed, especially not this size. The 4-inch and the 8-inch versions are a little bit easier to change the membranes, but not the 2-inch versions. This right here is the drain. So when you're done with your system, you will flush it with clean solvent. Everything comes out this drain. There's a couple valves here to allow you to drain the system. And another feature about this machine, which I think is noteworthy, especially on the 2-inch system, is the fact that you can use just one of these housings. So you've got 4. Some of these elements can be extremely expensive. I know that some manufacturers, membranes may cost $3,000-$4,000, while the ones that we're using at this moment are in the range of $300 to $800 for membranes, depending on the application. But should you wish to test, especially one of these new expensive membranes from time to time, with this valve here, you move this valve and it effectively shuts off the other 3 housings. Therefore, you can test just one membrane. Of course, your throughput is going to be less. You won't be able to process as much solution with one membrane because you have a fourth of the surface area, so you're going to process less, but you'll be able to test whether that membrane works for you or not. We don't manufacture the membranes, so you can purchase membranes from us and from any vendor pretty much, as long as they're the right size, and our sizes are industry standard. But there are some membranes that do well, and new membranes will come up from time to time, so you can test. I know there are some manufacturers where small membranes may be in the tune of $3,500 to $7,000 or more per membrane. So if that was the case and you really wanted to just see if those membranes actually worked, instead of spending the money and buying all 4 membranes, you could just buy one and test it. Because it's only a quarter of the surface area of your setup, then of course your filtration rate will be a lot less. So instead of, say, you're expecting 30 gallons per hour, you might only get 7 or 8 gallons per hour. And but at least you'll be able to test and validate that membrane to make sure that it's right for your application and develop an SOP with that. Another question we get a lot is as far as safety. Of course, this is a pneumatically powered system. We also have electrical systems that are wired to be intrinsically safe, but at least 2.5-inch systems, they do not get ASME rated. ASME ratings start at 6-inch diameter housings. So even if you wanted to, this machine could not be ASME rated. That doesn't mean it's not safe. It's manufactured to ASME standards, all kinds of safety standards. Nonetheless, these machines do operate at 1,000 PSI sometimes. They are capable of operating from somewhere between 100 to 1,000 PSI. All of our components are high quality, produced to really high standards. Chemical compatibility of these systems is very varied. We're able to do a lot of solvents, including pentane, and that's due to the choice of gaskets that we use in our pumps and in our housings. And also, that'll also be dependent on the membrane that you choose to purchase, because not all membranes are compatible with pentane, but those options are available, selected accordingly.